Welcome everyone. What we're going to do today is we're going to go over temperature conversions. First, we've already mentioned how heat is the flow of energy due to a temperature difference. We talked about how heat always flows from the hotter object towards the cooler object. Well, temperature has to do with kinetic energy. In fact, it's the measure of the random motions or average kinetic energy of the components of a substance. The higher the kinetic energy, or the higher the temperature, the higher the kinetic energy. You're going to see here that they're directly proportional. Okay, so you got high kinetic energy will give you a high temperature. And you can see on the bottom there are three scales. We have Fahrenheit, Celsius, and Kelvin. The official SI unit for temperature, if you recall, is the Kelvin scale. Now we're going to talk a little bit more about these three scales. If you look here, Fahrenheit is used in the United States, whereas Celsius is used in pretty much all the other countries. Now the Kelvin scale, notice it's also known as the absolute scale. What that means is that there are no negatives in the Kelvin scale. You will only have negative values in both Fahrenheit and Celsius. You can also see that Fahrenheit and Celsius are separated in degrees. The Kelvin scale does not have a degree symbol. And as I mentioned earlier, when you compare temperature in the Kelvin scale, temperature is directly proportional to the average amount of kinetic energy. And again, we're using the Kelvin scale as a reference. Now, the reason we mentioned earlier that there's no negatives on the Kelvin scale is because 0 Kelvin, which has a specific name, is known as absolute zero. There is no temperature colder than that. There is no -1 Kelvin. At absolute zero, that is where matter completely stops moving. Atoms completely cease movement. The electrons completely stop. Nothing is moving at that point. So that is where absolute zero, that's the definition of that. And not any type of matter will have any type of movement. Now, the equivalent of absolute zero in the Celsius scale is -273 Celsius. And it's -459 in the Fahrenheit scale. Now, I will present some formulas that will allow us to convert from one scale to the other in a few minutes. Now, let's look at a couple of other popular temperatures. We probably know that water freezes at 0 Celsius and boils at 100. The equivalent of that in Fahrenheit would be 32 degrees Fahrenheit would be the freezing point of water. So if you wanted to snow in your area, it would have to be at least 32 or below for you to see snow. The boiling point of water in Fahrenheit is 212. Okay? Now in Kelvin, that would be, the freezing point would be 273 Kelvin, and the boiling point would be 373 Kelvin. So I'm showing you these three scales, and you could see the equivalent. These are the boiling points of water using the three different scales, and these are the freezing points of water also using the three scales. So when you compare Fahrenheit and Celsius, the Celsius degree is 1.8 times larger than the Fahrenheit degree, and we use that difference to come up with a formula that allows us to convert from one scale to the other. And if you divide this right here, that's where you get the 1.8. So if you were going from Fahrenheit to Celsius, what you would do is you would basically first use order of operations. You would you would subtract 32 from the Fahrenheit, and then you would get that answer and divide it by 1.8, and that would complete your conversion. And we'll do that in just a second. If you look over here, I have the two formulas, and if you want, we could put the little degree signs here, because they do have a degree. This formula down here is what happens when you're going from Fahrenheit to Celsius. That's what you would use. So let's say if we had something, let's say they say it was 85 degrees Fahrenheit, okay? And that would be, let's say, the weather in Miami. And you want to find out what would that be in Celsius. So what you do is, using this formula right over here, first you do what's in the parentheses. We're going to put this number right in here. So you're first going to get 85 minus 32. You're going to do that part first, and then you're going to divide by 1.8. So when you go ahead and put it in your calculator, just remember order of operations. So 85 minus 32 is 53. And then what we're going to do is we're going to divide that by 1.8. And since the last thing we're doing here is division, we'll go ahead. Notice there's two significant figures here. We'll round it to 2. I got 29.44. Let's just call it 29. And that would be the answer in degrees Celsius. It would be 29 degrees Celsius. Okay? So let's say we were going from, and we'll use a different color here. Let's say we were going from Celsius to Fahrenheit. You would use this equation over here. And let's say that we had something like 37 degrees Celsius. And we wanted to convert that into Fahrenheit. So what you would do is the 37 would get plugged in right here. In fact, what you're doing first is what's in the parentheses. So you're going to get the 37, and you're going to first multiply it by the 1.8. And then after you multiply, you're going to add 32. So you go 37 times 1.8, and you do get 66.6. And then you're going to add 32. Now I'm going to show you how I'm going to do the significant figures here. You get 98.6, okay? And if we were to round this, 98.6 would be the unrounded answer, and that would be Fahrenheit. If we were to round this one would round to 99 Fahrenheit, okay? Which, by the way, 37 degrees Celsius would be the body temperature. I don't know if you're familiar with this, but the body temperature is 98.6 in Fahrenheit. That would be the equivalent of 37 in Celsius. Okay, so these are the two formulas that we use to go from Celsius to Fahrenheit or vice versa. Now, going from Celsius to Kelvin is a lot easier. You see, the size of the degree on the Kelvin scale is the same as the Celsius scale. So that means that technically the Kelvin and the Celsius are both 1 point times larger than the degree Fahrenheit. Now, there is no direct formula to go from Kelvin to Fahrenheit. However, because Kelvin and Celsius, the degree symbol is equivalent, to go from Celsius to Kelvin, it's pretty easy. All you do is, if you're going from Celsius to Kelvin, you add 273 and you get your answer in Kelvin. If you're going backwards and you're going from Kelvin back to Celsius, then what you're going to do is you're going to subtract the Kelvin minus 273 to get your answer. So let's take a look at an example. If I had something that was, let's say, negative 45 degrees Celsius, and I wanted to change that to Kelvin, okay? What I would do here, very simple, if you plug the number into the formula, it would be negative 45, and then you would add 273. Okay, remember, you can get negatives in Celsius and Fahrenheit. It is the Kelvin scale that does not have any negatives, and that is one of the reasons it's called the absolute scale. So when you add these two numbers, you're going to get 228, and then, of course, we're converting it to Kelvin, and that would be your answer. Okay? Now, I'm going to show you a couple more examples. Let's say that we want to go from Kelvin back to Celsius, and let's say that something was 315 Kelvin. We wanted to change it into Celsius. So the formula is that if you want to go to Celsius, what you do is you do Kelvin minus 273 will give you degrees Celsius. So you would go 315, you would subtract 273, and you would get 42 degrees Celsius. Okay? Now, let's say that I wanted to go from, 315 Kelvin to Fahrenheit. Well, in order to do that, you would first have to go from Kelvin to Celsius, which was what we just did right here. And then you would have to do another step to go from Celsius to Fahrenheit. Okay? So in order to do that, to go from Celsius to Fahrenheit, if you recall, what we do is we get the Celsius, and then you multiply it by 1.8, and then you're going to add 32. And that's going to take us to the answer. So we're going to put the 42 that we got from the first step. And remember, the key with these is that you do the correct order of operations. So you're going to multiply here. You get 75.6. And then we're going to add 32 here. So when you add the 32, you end up getting 107.6. Okay? If we are strict with significant figures, you would round this to 108 Kelvin using the addition rule, which is what you did last, because that's what we did here. We added 32. I wrote it vertically over here. Okay? If you left it without rounding, you would then have, and I put the wrong unit there, I apologize. You would have 107.6. And the unit is Fahrenheit, not Kelvin. So that's how you would do that. Okay? And let's see if we could do one more going backwards. Let's go from Fahrenheit, and let's see if we can go to Kelvin. Now, again, what you have to do is go from Fahrenheit to Celsius, and then from Celsius to Kelvin. So let's say that we had something that was, I don't know, a little bit hot, maybe higher, a higher temperature, maybe 115 degrees Fahrenheit. We want to find out what would that be in Kelvin. So the first thing we got to do is we got to go from Fahrenheit to Celsius, and we'll use the first formula. So first, what we're going to do is we're going to put the, if you recall, the formula is that Fahrenheit over here like this. Okay, we're going to put that over here with parentheses. We're going to subtract 32 and then divide by 1.8, and that'll give us the Celsius. So we're going to have 115 minus 32. We're going to do that first because it's in parentheses, and then we'll divide by 1.8. So once you subtract, you're going to get a numerator of 83, and then we're going to go ahead and divide that by 1.8. And I get 46.11 and change. I'm going to go ahead and round that already to 46 since we have, two significant digits there from the formula. Okay, so we got 46. And then what we're going to do is the next step is to go from Celsius to Kelvin. If you recall, all you do is you're going to add 273. So we get the 46 that we got from the beginning, which is in Celsius now. And we're going to add 273 to get our answer. So when you add the 273, you're going to get 319. And the unit now will be in Kelvin. So 115 degrees Fahrenheit would be equal to 319 Kelvin. So just keep in mind that if you're going from Fahrenheit to Kelvin directly or Kelvin to Fahrenheit, either way, that there is no one formula that does it in one step. You have to divide it up into two steps. For example, the one I just did, from Fahrenheit to Kelvin, we first had to go to Celsius from Fahrenheit, and then from Celsius, we go to Kelvin using the other formula. So I want you to keep that in mind.